Hi, welcome to my tutorial on Desmos graphs, finding patterns in waves. So during week 7, we had two important assignments, finding patterns in waves so that we can encode information, where we use the PhET wave on a string simulation to collect data on the relationship between wavelength and frequency, and then the Desmos graphs, finding patterns in waves assignment, where we took that same data and entered it into Desmos and created graphs, and you were supposed to screenshot the graphs and turn those in. So let me just review the first assignment a little bit. That's the finding patterns in waves so that we can encode information. It was a series of 2 worksheets, so I've opened it up here, and there's now a tutorial in there that tells you how to take the measurements that you need to take with the wave on a string simulation. The worksheet is 2 pages. There's a front, back, and then the third page is separate. That's the data analysis that you do after the Desmos graphs. So this is what here it is. This is what the worksheet actually looks like. So here's my electronic copy. First page, we filled in together. Second page, there's just some explanations there at the top. And I'm just going to screenshot it now and show you how I would fill it in. Okay? So you're going to be filling yours in differently, of course, because you're going to collect your own data, and you can use that other tutorial for that. But just so that you know, I've got amplitude of 1 centimeter here, but you can use any amplitude as long as you keep it the same throughout the experiment. I've been using 1.25 lately, which is the max. And really important, though, is that you have no damping on. Tension could actually be high, medium, or low, or anywhere in between, as long as you keep it the same the entire time. So it just has to be the same throughout the experiment. And then, of course, you want to have all this stuff checked. All right. So I took some measurements already, and I'm going to write them down, and they're very weird. So you will definitely not have the same ones as me. All right. So I chose frequencies, kind of random but spaced out. And it's good to have them in ascending or descending order, from biggest to smallest or smallest to biggest. All right. I'm only going to write Hertz once, 1.82, 1.31, 0.87, and 0.66. And so then the wavelengths that I got to go with that were 1.6, and wavelength is in centimeter, 2.1, 2.8, 4.38, and 5.68. Okay, and then I also measured wave speed. I'm not going to fill that in right now. For the tutorial, I'm just going to focus on frequency and wavelength, because you're going to do frequency and wave speed graphing the exact same way. All right, so I'm going to go ahead and save this screenshot. And then we're going to go into the Desmos assignment with that data. So back to modules. And then I see Desmos graphs, finding patterns in waves here. And I'm going to use the first link to take me into Desmos. First thing when you get into Desmos, you want to make sure that you're logged in. Log in with Google, and you should see your name at the top of the screen after you do that. When you turn in your screenshots, your name must be on the screenshot, or I will not accept it. All right, so next thing I'm going to do is enter in the frequencies that you just saw me put into that data table. So I have them here in front of me, so I'm just going to try to get those in quickly. This is exactly what you will do, but with your own data. And 0.66. Then I'm going to put in the wavelengths that I got. And whoops, didn't get in my decimal point there. 3.8. Okay, so I've got my data in now. You only need 5 data points, and you can see that there's points actually showing up on the screen, especially when I get rid of my calculator. There we go. Now, one thing to know is that you can pinch in or out to make, or you can move the screen around on the graphing part of this display. Another thing to know is you can save the graph at any time. You'll see in the upper left-hand side of the screen, it says wavelength versus frequency, and there's a green save button. So I'm going to click on that. And that way, if anything happens, I'll have a saved version of this. I can also rename the graph. So I'm going to leave the wavelength versus frequency part in, but I'm going to name it with my name. Just one more way to make sure that I know that it's my data and I won't lose it. Okay? So there it is. It's all saved. So I'm ready to do some more work now, and I can save it again at the end too, because we're not done yet. All right, so on the left-hand side here, I can move this up and down, this little menu of different operations here on the left. And what I want to focus on now is how to make one of the lines on the graph line up with my data. And you can see the data has that little, there's green dots, but there's these little orange error bars on each of the data points too, and that's why they look odd like that. All right, so C stands for constant. So this first kind of option here where it says C equals 2 allows me to move a slider back and forth and choose a constant. Each one of the lines on the graph represents an equation. So there's a blue line, a red line, a green line, and a purple line. And I want to move the constant slider back and forth till one of those lines lines up with my data. And if none of them lines up, it means that your data is not good. Okay, so you probably made a mistake in how you collected it. So there we go. I'd say that that one probably lines up the best right there. And I'm also moving this little guy out of here now. All right, so it looks like the green line lines up with my data with a constant of 3.9. And so actually I think I could slide that down just a little bit. 3.8 probably lines up a little better. All right. Now to deselect the lines or the equations that don't match, I am going to touch the little colored squiggle to the left of each of the equations that don't line up with my data. So there goes the red squiggle and the blue squiggle and the purple squiggle, so that all I have left now is the green line on the graph. So I'm almost done at this point. I'm going to go ahead and save it again just to be safe, and I'm going to move the sidebar up a little bit, and then you're going to see a place where it says label, write in mathematical model here. So I can delete the typing that is in there, and we are going to type in the equation that we found. And you can move this thing up and down in order to do that. So I see that my equation is wavelength is equal to C over F. C has a value though. C is equal to 3.8. That's what we did when we moved the slider. So it's going to be W is equal to 3.8 over F. All right, so I'm going to type that in right here. And just have to use my regular typing pad to do this. W is equal to, oops, probably had to get a little space in there. And that was 3.8 / for divide, and then just the letter F for frequency. Wavelength is equal to a constant, 3.8 divided by frequency. That's what we're saying. Okay, then I touch the graph to get rid of the typing menu. Anytime you want to move the little equation around, you see how it shows up on the screen now? You want to put your finger on the dot to move it. Okay, so now the equation's on the screen. I've got my equation, and I can also see it here on the sidebar, and I can see my constant on the sidebar. I'm going to save one more time. I see my name on the screen, the constant, the equation, and the line. I'm ready for my screenshot now, and this is what I will hand into Canvas. All right, so that one is done. And then what you would do then, if you were actually doing this assignment, you go back into Desmos Graphs assignment, click on the second link. That's going to take you to the wave speed versus frequency graph, and I'm already logged in at this point. You're going to enter your wave speed versus frequency data right here, just like we did before, only this time you'll notice that you have a V right here instead of the W. All right, so it's frequency and V is equal to the wave speed that you should have found in the finding patterns and waves so that we can encode information assignment in that data table that I showed you before. All right, and you'll go through the same process after you enter your data. You're going to move the slider back and forth here, and you're going to figure out which value makes one of the lines line up with your data points. Then you're going to deselect the lines that don't match, type in the equation, save everything, and take a screenshot with the constant, the equation, and the line in it. All right, so hopefully that makes it a little more clear what I'm expecting you guys to do with this. And if you have any questions, let me know. But my hope is that you'll be able to work on it now independently.